Okay, this is my second video from 10.1. What we're going to talk about is identifying the null and alternative hypotheses, because over the long run I think you'll find that this is the most complicated part of the project. So here's our first example. Test the claim that the mean body temperature is equal to 98.6, and you can consider this an Easter egg, a little treat for those of you who still have your project yet to bash out. Probably don't, but because your project is due on Tuesday and I'm making this video on a Monday. But anyway, this was from your project. Test the claim that the mean body temperature is equal to 98.6. So first, this is a four-step process here. So, 4 steps. 1, write the claim in math. Now the second step, some people think, why are we doing this? Write the complement of the claim. And we really only need the complement for the tricky cases of the claim. 3, the null is always whatever the parameter is equal to whatever the value in the claim is. But 4, this is where we might need the complement. 4, the alternative hypothesis is either, it could be the claim or it could be the complement of the claim. It'll be whichever doesn't have equality. And the idea behind this is the alternative hypothesis has to be a true alternative to the null hypothesis. If the null always has equality, the alternative can't have equality. So in our example, write the claim in math. Well, our claim is either going to be about means or proportions, because that's all we're covering this quarter. So that simplifies it down a little bit. And then I have a clue up here. I'm testing a claim about a mean. And the mean is either equal to something, not equal to, greater than, less than or equal to, greater than or equal to. In this case, it says equal to. So that wasn't so bad. What is it equal to? 98.6. Our complement will be all the cases that don't include the mean being equal to 98.6. And that will be the mean being any other number other than 98.6, aka not equal to. The null hypothesis is always equality. Mu equals 98.6. And so the tricky part is the alternative hypothesis. Is it the claim? Is it the complement? It'll be whichever one does not overlap with the null. Well, the claim is the null, so it's going to have to be the complement. So this is actually one of the tricky cases, one of the cases where the alternative was not the claim. If it's not the claim, then you need the complement to decide what the alternative hypothesis will be. Okie dokie, so let's try a second example. Okay, this is my next example, and I left the instructions up there because it's going to be the 4-step process every single time. So 1, write the claim in math. 2, write the complement. 3, the null is always equality, and 4, the alternative is the complement or the claim, whichever does not have equality. So the first step, the claim, is the claim in math. Oh, look at that. It's means again. How nice am I? And is at least, so we need to be able to translate at least. So the way to answer that question is to throw in a couple of data values. Is 75 at least 76? No, it isn't. So it won't be less than. Is 77 at least 76? Yes, it is. So it will be more than. But what about 76 itself? 76 is at least 76. So it can be 76 as well. The complement of the claim is mu is less than 76. The null, easiest part once you get the hang of it, the null will always be equality. And the alternative, it's either the claim or the complement, whichever one does not contain equality. So in this case, it's mu less than 76, which is quite different from the claim. So sometimes sorry, that was supposed to be the alternative, but sometimes the alternative is not the claim. In fact, sometimes it's 100% not the claim. Okay, let's try my third example. So here's my third example. Test the claim that among those who file tax returns, less than 1/2 of them file through an accountant or another tax professional. So what I'd like you to do is turn off the video and have a crack at doing it by yourself. Make something up. Go ahead and be wrong. Go ahead and make mistakes if you're not 100% sure, and then learn by adjusting and asking yourself, okay, why was this not right? Okie dokie, stop the video. I'll wait here. Okay, so let's have a crack at doing this guy together now. Now, please notice in this example, neither the word mean nor any of the synonyms for proportion, percentage, percentile, probability are written into this claim here. So we're going to have a question here. Is this about means or proportions? So you need a rule of thumb for figuring out which one we're looking for. Means is for quantitative data. Proportions is for qualitative data. And so we're going to ask ourselves, what data did we collect? Say we polled 60 people and asked them about their tax returns, 60 people who file tax returns. And what are we asking them? And what are they giving us back? Are they giving us numbers, or are they giving us categories? And what they're going to give us is yes or no answers. This is yes, I do use a tax professional. No, I do it myself. So it's qualitative. I can't take the mean of a bunch of yeses and nos, but I can count the proportion of yeses. So yeses is the data that I'm looking for. Proportion of yes, I use a tax professional. So that's what we're checking. And our claim is that the proportion is less than 1/2. There you go. The complement is the proportion is greater than or equal to 0.5. Well, that won't be the alternative. The null hypothesis is that P is equal to 0.5 because the null is always equality, and the alternative will be either the claim or it'll be the comp, whichever one does not overlap with the null, and that's going to be the claim. P less than 0.5. Okie dokie, that's all I've got on this video.